Multiplying and dividing rational expressions is actually easier than adding and subtracting rational expressions, just like the same is true for fractions. For example, if I say 2/3 times 1/8, what do I get here? All I have to do is multiply the numerators and multiply the denominators. So here I get 2 over 24, which we can reduce down to 1/12. Now, this is a good example because I could have done something, if I was clever, I would have noticed that there is a 2 in the numerator and in the denominator. So I could have canceled those out at first, because when you multiply these are one term. So 2 is a common factor in the numerator and in the denominator. It ended up with 1/3 times 1/4, which multiplies to give you 1/12. I have a couple examples of rational expressions that I want to multiply or divide. So for A part, you see I have y squared plus 3y minus 4 over y squared minus y minus 20 times y squared minus 6y plus 5 over y squared minus 7y plus 6. And that sounds like a lot. And I don't want to have to FOIL out all of these quadratics together. So I think what I should do maybe is factor everything and see if I have some stuff cancels out, and then deal with what's left. Okay, so in the numerator, let's see, y squared plus 3y minus 4. Two things that multiply to give me -4, add to give me +3. How about a +4 and a -1? Okay, in the denominator here, I'm thinking of two things that multiply to give me -20, add to give me -1. So what about -5 and +4? Okay, now in the second numerator, two things that multiply to give me 5 and add to give me -6. I think that might be a y minus 5 times a y minus 1. And then lastly, two things that multiply to give me +6 and add to give me -7. I think it's going to be a y minus 6 and a y minus 1, like that. Okay, now what I see here is once everything's factored, and since this is multiplication, this is all considered to be one term. So I can cancel some stuff out. In fact, I see that I have a y plus 4 cancel out from the numerator and the denominator. I have a y minus 1 cancel out. And I have a y minus 5 cancel out. So actually there's not much left to multiply. What's left in the numerator is a y minus 1. And the denominator I'm left with a y minus 6. And there's my answer. It's simplified. I multiplied them together. So actually when you're multiplying these together, you just cancel a lot of things out and there's not much left to deal with, and so the arithmetic's not too bad. Dividing rational expressions is just as easy as multiplying them. We just have to remember one thing. So if I say something like this, 1/3 divided by 2/5, or maybe you'll see it written like this, 1/3 divided by 2/5, they're the same thing. It looks confusing, but dividing by a fraction is the same as multiplying by its reciprocal. So 1/3 divided by 2/5 is the same thing as saying 1/3 times 5/2. Once we have multiplication, it's pretty straightforward. I have 5/6. Same here. This is the exact same thing. Dividing by a fraction is the same as multiplying by its reciprocal. So that's 1/3 times 5/2, which gives me 5/6. Now I'm going to show you how that works with rational expressions, and I hope it makes sense. Okay, for this next one, I just have to remember that division is the same as multiplying by its reciprocal. So it's not too bad. I'm going to start with the first one. I need a factor, and I'm thinking of two things that multiply to give me -4 and add to give me -3. So how about y minus 4 and y plus 1? Okay, and the denominator is not much to do, and I'm going to leave this as division for the moment because I want to factor this second numerator. And I need to think of two things that multiply to give me -8 and add to give me -2. Okay, so that's going to be, how about -4 and +2. Okay, now what I need to do next is remember that dividing is the same as multiplying by the reciprocal. So I have a y minus 4 times a y plus 1 all over y minus 2 times the reciprocal of the second term, which is y minus 2 over y minus 4 times y plus 2. Now I can see, since this is multiplication, this is one term, I can factor out the y minus 4 from the numerator and the denominator, and a y minus 2. And so I'm left with a y plus 1 all over a y plus 2. Okay, and let me try to write that a little nicer. Alright, and there it is. There's the division. Okay, so multiplying and dividing rational expressions is usually not too bad. It's just a matter of factoring, canceling out like terms, and then deal with what's left. If you have any questions, please let me know. I'd be glad to help, and thanks for watching.